Hello everyone. Let's get started. In the last video, I said the due date for the second exam is on Monday. It's on April 6th. But later on, I find exam two questions you may need. For exam two questions, you may need more time to finish this. So I extend the due date for this exam to this Friday, which is April 10th. So I feel like you guys could have enough time to finish this exam, considering the current situation. At the beginning of today's class, I want to go through exam two questions. Like I will give you some instructions, like few initial steps of how to solve each question. So I feel or I wish this class, this lecture will give you some advice or gives you some help for finishing this exam. Alright, without further talk, let's get started. For the first question, we have a circuit with AC source, right? We have a circuit with AC source, an inductor, resistor, capacitor, and another inductor, right? The first question is what's the value of the source frequency? So to find source frequency, you need to look at the expression of this AC source, right? The general solution or the general expression of the AC source is A cosine omega t plus phi, right? And here for this expression, we have 100 cosine 1000 t. So we can compile these two expressions, and you can find capital A is 100, omega equals to 1000, and phi equals to 0. A is the magnitude, right? It's the magnitude of this source function. Omega is the source frequency, and phi is the phase angle. So the answer for the first one is very obvious. Omega equals to 1000 unit is radian per second. Okay. Alright, and for the next one, write V1 in the phasor form. So this expression is a cosine, is a time domain function, right? And in chapter number 4, we mentioned so many times about excuse me. We mentioned so many times about how to find the phasor form of a cosine function or a time domain function, right? We just need to pick the magnitude and the phase angle information. For this expression, we don't have phase angle. Phase angle equals to 0. So the phasor form of this source function is 100 and 0 degrees. Okay. Or you can directly write 100 because 100 excuse me. Because 100 0 degree is the polar form, and 100 this single number is the rectangular form, right? Alright, and then the impedance for L1, L2, R1, and C1. So for this question, you just need to use the expression, the formulas to calculate impedance of inductors, capacitors, and resistors. For inductors, the impedance ZL is J omega L, and you find omega in the first question. You have L given by the question, so just need to plug in and find ZL. Then ZC is 1 over J omega C, right? Also, you just need to plug in values since all values are known. For the last one, ZR is just the resistance itself. Alright, for the V naught, this one actually is a little bit challenge, but I think you guys can handle that. After you change everything into impedance, after you find ZL, ZC, and ZR, and then you can treat all components as resistors, right? So to find V naught, you can first combine ZC1 and ZL2 because these two guys are connected in series, right? After you combine these two guys together, you get a new circuit look like this. And this is the combined impedance of C1 and L2, right? Let's call it T1, okay? Combine ZC1 and ZL2 to get ZT1. After you have ZT1, you see R1 is in parallel with T1. So in the second step, you can combine ZR1 and ZT1 because they are connected in a parallel connection. And you can find the overall impedance, right? And then the circuit look like this. Let's call the new or the combined impedance as ZT2, okay? And then at this step, you don't need to combine these two components because now you can use the voltage division law to find what's the voltage across T2. Let's name it as VT2. This is Vs. Vs is 100 volt, right? The phasor from. And ZL1, you can find this value by using this formula. And you have the value for ZT2. So VT2 is going to be ZT2 divided by ZL1 plus ZT2 times Vs. That's the voltage division law, right? And after you find ZT2, you can go back to this circuit because the voltage across this branch is VT2, which means the voltage across T1 is also VT2. And then you can go back to the original circuit. I don't want to redraw it, so let me directly indicate in this diagram. The voltage between these 2 points is VT2, okay? And you can see between VT2 is consisted by or is included with C1 and L2. So VT2 equals to VC1 plus VL2. Therefore, you can plus you know the impedance of C1 and impedance of L2. Therefore, you can use voltage division law to find V naught, right? V naught is gonna be ZL2 divided by ZL2 plus ZC1 times VT2. Okay. Alright, so that's how we find V naught in this question. That's one method to solve this problem. You can also use other methods. For instance, you can use nodal analysis or mesh analysis, right? Because after you convert all components into impedance, all DC analysis methods are feasible. Okay. But I think the method I show here maybe is the easiest one because I don't need to do so many calculations. Right, for the second problem, it's a mesh analysis problem. First one, draw mesh currents I1 and I2. Because we have two blocks or two meshes, so for each mesh you can give one mesh current, and as I mentioned previously, mesh currents are always clockwise direction. Okay. Alright, so that's the first one. Assume the voltage on R1 is VR and the voltage on C1 is VC. Assign the polarity signs on VR and VC. Based on the match current direction, VR is positive on the left side, negative on the right side. VC is positive on the left side, negative on the right side. Okay. So that's for the first question. The second question is write the rectangular form of V1 and V2. V1 is the voltage source on the left. V2 is the voltage source on the right. These two expressions, which I highlighted here, are polar forms, right? And the question asks us to find what's the rectangular form of V1 and V2. So to find the rectangular form, 20, 90 degrees is equivalent to 20 cosine 90 degrees plus j times 20 sine 90 degrees, right? And you can do this calculation and find the result. For the second one, 10, 0 degrees, that is equivalent to 10 times cosine 0 degrees plus j times 10 times sine 0 degrees. Okay. Alright, third question, write KVL equations for two meshes. For the first mesh, let's start with VR. That should be positive VR plus V naught minus V1 equals to 0, right? And for the second mesh, let's start with VC. That should be positive VC plus V2 minus V naught equals to 0, right? And then represent VR, VC, V naught using match currents. VR can be represented by I1 times R1, because I1 is the Ohlen current flowing through R1, right? VC can be represented as I2 times ZC1, right? ZC1 equals to minus 5J ohms, right? Given by the question. V naught is between two meshes, and it's a little bit different with VR and VC. You need to find the overall current on this inductor, and that should be going down because the polarity of V naught is positive on top side, negative on the bottom side, which implies the current on the inductor is flowing down, right? Alright, so the current should be I1 minus I2 times ZL, right? And ZL is 10J ohms. Or after you represent VR, VC, and V0 by using match currents, you can plug back these three expressions into two mesh equations or two KVL equations, and you can solve the value for I1 and I2, right? Alright, so after you find I1 and I2, plug these two values back into V naught's expression, you can find what's the value for V naught. Here, you can first do the calculation by hand, and if you know how to use MATLAB to solve these two equations, you can also use MATLAB to verify your result. But in the exam, in your exam solution, or in your submitted exam, I need to see your solving procedures. Okay. But don't write too much. Just show few steps of how you attempt to solve these two equations, and give me the final answer. Okay. And also highlight the final answer by using a square. Okay. Or circle your final answer with squares. Alright, problem number 3. Nodal analysis. For this one, this question actually is not very hard. For this circuit, you can assign the voltage, unknown voltage variable on node A as VA, right? And then the current on R1, you can say, is flowing from VA to this point, to V1, right? And of course, you need to find, in the first question, you need to write the rectangular form of V1, and that should be 100 volt. The the current on this branch, you can say it as IC1, which is flowing down, and the current on this branch, that is S1, and the polar front is 190 degrees. The rectangular front is just J, right? And then you just need to represent, you can write KCL equation for node A, which is IR1 plus IC1 plus S1 equals to 0, because these three currents, they are all leaving currents, right? Excuse me. And then you can find what's the expression for IR1. IR1 equals to VA minus V1 divided by 100, right? VA minus V1 is the voltage across R1, and R1, the resistance is 100. IC1 is VA minus 0 divided by minus 100J ohms. And S1, given by the question itself, is just J, right? Alright, so after you have these three expressions plugged back into the KCL equations, you can find what's the value for VA. And after you have VA, V naught is actually equals to VA, right? So that's problem number 3. For problem number 4, consider the following bandpass filter and answer the following question. So for this one, you need to look at what's the formula to calculate central frequency and what's the formula to calculate the bandwidth, right? These two pieces of information can be found in my lecture let me give you the specific date, so you guys don't need to look it up. Through the YouTube views number, I can expect, or I can estimate how many people are watching, are attending the class. So, I mean, each lecture is very. You can skip some lectures, if you are familiar with the topic already. But some topics are very important and are new, which I didn't introduce before. So for those lectures, I recommend you guys to watch through the video. In a sense, it's a video, so you can skip some part, right? You don't need to watch the whole video. You just need to pick some information you need. Alright, so for the bandpass central frequency and bandwidth formula, please look at the lecture on March 25th and 27th. Okay, these two lectures introduce these two topics. Okay. Alright, for the problem number 5, it's a very similar problem to problem number 4. The first one, right, the transfer function of the above circuit. As we mentioned in the lecture, transfer function describe the relationship of output voltage and input voltage. For this circuit, V0 or V0 is V out, right, and V1 is V in. So the relationship of these two variables, if you look at the circuit, is a single series loop, right? And V0 is the voltage on R1, which is part of the total voltage, right? So you can write V naught equals to ZR1 divided by ZL1 plus ZC1 plus ZR1 times V1. That is the voltage division law. And after you plug in the expressions of ZR1, ZL1, ZC1, that is R1 divided by J omega L1 plus 1 over J omega C1 plus R1 times V1, right? And you know the value for R1, you also know the value for L1 and C1. You just need to plug in these values, right? And then simplify the expression, you can have the simplest expression. So please be well, the question asks you to find the simplest expression, okay? So try to simplify this expression until you couldn't simplify anymore, okay? All right, here again, the central frequency, bandwidth, and quality factor. These three values, we have formulas to calculate them, right? And this formula can be found in lecture March 27th, 25th, and 27th. Okay, go ahead to look at this information in these two lectures. Okay, right. So that's all I want to talk about for the exam number 2. And please let me know if you have any questions, no matter it is regarding the homework questions or it's regarding the exam questions. But for exam questions, I won't tell you the final answer. I won't give you the final solution because that is still exam, right? But I will give you instructions of how to solve this problem, right? So please do not hesitate and contact me if you have any questions. Okay, all right. So that's all I want to talk about for today's class, and I will post a new homework after today's class, and the due day is not due in the next week. It's not due in this week. It's gonna be due in the next week. Okay, it's gonna be due in the next Friday. Okay. All right. Please let me know if you have any questions. And keep contact and stay safe. Stay safe. All right. I see you guys next time.